Are you in systems or requirements engineering, and do you have the task where you have to create subsystem requirements from a pretty vague set of stakeholder needs or customer level requirements and wishes? If so, what I like to suggest to people is try these three things. If you can get these three artifacts and then, as a bonus, get it in front of the customer and ask the question, what are we missing? From that, you're going to be able to get 80% complete requirement specs out fairly straightforwardly or something. I wouldn't call it easy, but at least you'll have the input material to at least get some specs in there and start getting more formal requirements reviews. So, okay, we're going to go through just all three of them. One, my favorite tool actually is the context diagram. Now, I was asked to do a context diagram years ago, and I had the system that we were working on, and then I was tasked with just finding everything that touched. Okay, and then you have a line to, let's say, the environment or the next assembly or whatever other pieces or systems that it interacts with. So think of a diagram. It's got a thing in the middle, and then it's got kind of like a spider web, tentacles going outward to each of the other things that it touches. That's helpful because your requirement spec is going to reflect those interfaces. Okay, and sometimes each interface could be its own interface document as well. So that's the first thing. Try and just get this context diagram down on paper, even if you just sketch it out. Okay, you don't need MBSE at this point, but you need something. The second thing is, now that we have the context diagram, focus on the actual system and see if you can get a physical architecture of that system. Okay, so maybe it only has 10 or so blocks. Okay, a power supply, a controller, a interface, or a actuator. Okay, if it's doing some of that. If it's software, then maybe there are some physical blocks of the software, like the CPU or the logic unit or the storage area or a different type of controller, the USB controller, let's say. If you could just break down a physical architecture of this thing, now we've got two of them. We have a context diagram, we have a physical architecture, and then each piece in the physical architecture will have requirements, and then each interface between elements of the physical architecture could also have requirements. So now the third thing is, and you can do this in a list or in a diagram, it's try and capture the main functions of the software or the hardware product that you have. What does that mean? So let's say for an airplane, okay, hang with me here. You have the airplane fly safely through the air. Okay, that's the main function. Well, the other function is, carry passengers. There's maybe a function of burning fuel. Okay, but just, again, top level functions and then how they interact. So in flying safely, you would also have functions of provide heating and air conditioning to the passenger cabin if it's a passenger plane. But basically, if you can get the main functions down of the system, and even better, get it in some kind of architecture or hierarchy diagram. Would it be more than 2 or 3 levels? I would not put more than 20 blocks on the page. But now, if that's the third. Now we've got 3 things that's going to help us: the context diagram, physical architecture, and the functional architecture. Then take a look, see if the functional architecture drives a missing physical block that we need to put in, or maybe the physical architecture, like the power supply, says, oh, well, we have to provide power. All right, so now there's a function. Okay, and then you look at the context diagram, and again, it's a play between these 3. Okay, you see there's an interface that has an RF interface. Okay, well, for that you need an antenna and an amplifier in your physical architecture, and then the function is going to be transmit data, or transmit or receive data. Okay, so the 3 of them complement each other to where even within a couple of weeks, you're going to have a basic picture of the top level of the system, top or maybe one below. Now we can start writing shall statements. So again, for every piece in each of the 3 diagrams, does this have requirements? Does this link have an interface requirement? Whether it's in the context diagram or between 2 physical blocks. You just start writing these out. after, again, a couple weeks for a small system, you're going to have a semblance of a requirement spec in your hands. Now you're going to be able to take those to a review session and get in front of the customer and say, hey, look, these are the requirements we thought we heard. This is how we think it fits into your operational situation with a concept diagram, the context diagram, based on your concept of operations. This is our candidate physical architecture, and these are the functions we think it does. Then at each point, we have to ask, what are we missing? Okay, so the customer says, oh, you know what, it also has to communicate on a, making this up, RS-232 bus to our data backup server. Or, you know what, we use gig Ethernet on the backbone, but we use VxWorks on this other part of the system, and it's got to dump data on both. Okay, well, that's good to know. Okay, that's a context diagram thing, other networks. And then that would go back into our physical architecture. Okay, we have a VxWorks backbone. Again, hang with me here. And then for functional architecture, it'd be put data on the Ethernet line or put it on the VX, the backbone. Okay, so now you're in front of the customer. They read it out, and now all of a sudden, they can pick apart and say, okay, you're missing this, missing that, missing that. But you have something there. You have something to show the customer. Go in there for 2 days and just walk through all this stuff. And after that, I would propose that you've got probably about 70-80% of your subsystem requirement specs. And then once that's started, then you can go to lower levels about, okay, the power supply, capacitors need to be, 1 microfarad at 480 volts. Again, making this up. So bottom line is you can get from vague customer needs to a outline and a rough draft of subsystem component specs by going through this exercise and at least nailing down 3 things. Get a context diagram together, get a functional architecture, okay, and then also the physical architecture. So let me know what you think. Comment below if I'm missing something. I want to keep this simple. My experience with these things is that by doing this, I was on a transporter project where we just got some basic architecture down and we were able to write some specs. Now, as a bonus, on top of all this bonus, if there are use cases or sequence diagrams, if I had a 4th and a 5th one, then those would be the 2. Comment below if you want more information there, or DM me directly. But if you get the big 3, you're going to be 70-80% of the way there. So context diagram, the functional architecture, then the physical architecture. Okay, good luck. Writing requirements is not easy, but it's very rewarding. It's very much a technical task. Let me know if I could be of more assistance. And again, drop a comment if I'm missing something, or otherwise just let me know what you think.